How's it going, everybody? In this video, we're going to begin taking a look at a little bit of a deeper dive and a better understanding about how inter-AS option A, or back-to-back VRS work. So for those of you that have never dealt with inter-AS options or anything like that before, I was there at one point in time where I really didn't know what they were, or how they worked, and anything like that. But over a period of time, I've spent quite a bit of time working on inter-AS options and layer 3 VPN in general, and I've gotten pretty comfortable with the platforms and the capabilities. So what I'm going to do is I'm going to lay out exactly what's happening and how we're going to go about getting it all squared away. So right now, the way that this network is operational and working is we have a scenario where we have connectivity from our routers internally, right? So we have some sort of connectivity like this, and we have some sort of connectivity like this. Now, basically what's happening from a control plane perspective, we have control plane connectivity set up from the provider edge routers to the route reflectors. So any routes that the customer edges propagate through the EBGP peerings up to the provider edges are then reflected up to the route reflector and then pushed down to the provider edge router and then learned inbound by the remote CE. So that's how we're going to get connectivity in play. Now, we actually do have VPN v4 and VPN v6 BGP peerings to the ASBRs and on both sides. But what's not happening is we don't have any connectivity down to the ASBR level. So what's not working right now is we don't have connectivity down to here. So you might ask, well, what do we need to enable in order for that to actually happen? So I'm going to go ahead and break that down for you right now. So basically what's happening is what we need to do is on the ASBRs. So let's go back to red. This is an ASBR right here, which is route CSR5. This guy right here is an ASBR, and CSR6 is an ASBR. We're going to do this first on iOS, and then we'll do this on XR. So very similar configurations and stuff like that, but I'd rather break it down depending on what's going on. So we could do a connection between CSR5 and XR12. That would work too. But for right now, I just want to focus on the iOS routers. So what would need to happen is, and we only have one customer running right now. We only have customer 1. So what we would need to do is on CSR5 is, number 1, we need to create a VRF. So we're going to create the VRF. And actually, let me put this down here at the bottom. Number 1, we need to create VRF. And once we create the VRF, and we specify underneath the VRF a route target import and a route target export policy. This will allow reflected routes to be learned in on the ASBR. This will also allow routes that are propagated from the remote ASBR to us and from us to the remote ASBR. That will allow those routes to be reflected from the ASBR up to the route reflector. So right now, the way that it's working is, because we need this bidirectionally. Let's actually, let me remove this. If we were to do, this needs to be working and this needs to be working. Currently, we don't have that set up at all. So we need to create the VRF. And then once the VRF has been created, then the second thing is to apply it. Right? So I mean, that's obviously stating that it needs to go to the interface level, right? And then third, which is the big kahuna, we need to actually enable routing. That means we're actually going to go onto the ASBRs and set up some sort of eBGP peering between the ASBRs so that they can actually exchange routes. Now, if you're doing BGP between the ASBRs, then no redistribution is needed. if you're using IGP or static routing, then you need redistribution in order to do this. So just keep that in mind when you're taking into consideration what it is that's happening. So those are the main things, right? I mean, it's not a ton of stuff to go over. So what I'm going to do is I'm going to walk you through this, and then I'm going to do a packet walk with you and explain to you what exactly is happening and how it's working and things like that, and you know why we would see a label switch path and things like that where we are and where we wouldn't. So before we actually dive into it, where you will see an LSP, the LSP, the label switch path end to end, we will have one going from, which will be labeled. This will be from CSR1 to CSR5. And then you'll have another one from CSR6 to CSR8. Now, it might take a number of different paths through the AS backbone, but the point being is when it's working, you will see a label switch path. It'll obviously take the shortest path first. But between the connections here, let me use orange for example, between the ASBRs, this will be just IP routed. There will be an IP packet. So it'll be label, IP, and then label. So let's go ahead and dive into the actual setup of this and get it actually working. So let me go ahead and clear the screen and pull up Secure CRT. So on CSR5, if we were to look in here and do a show BGP VPN-v4 unicast all, right, we don't have anything, but if we do a summary, we should have a peering to router 1. And if we do the same thing for VPN-v6, we'll have a peering, but nothing will actually be, there won't be any routes. And you might wonder why that is. So let's do a debug BGP VPN-v4 unicast updates inbound, and we'll do a clear IPBGP star soft. And so what we're going to get is we're going to receive an update from router 1 and router 2, but what's going to end up happening is we're going to see the 10.1.19.0/24 and the 10.1.22.0/24. They're both denied due to the extended community not being supported. This is going to be the route target value. This is not allowed to come in on CSR5, so therefore he's going to drop the update. So let's go ahead and fix that problem. So we're going to go up to global config, and we're going to create VRF definition. I'm going to call it C1. I'm going to type in the route distinguisher is going to be 1:1, and the yeah, that should be correct. I think it should be correct. Show run VRF. Yeah. So it's the route target that's different. So we're going to type in the route target export is going to be 1:5, and the route target import will be 1:2 and 1:1. Now you'll notice I created the route targets, right? But I still don't have any inbound connectivity. I have to create the address family for it first. So I'll type in address family IPv4 unicast. And as soon as I do that, we receive the prefixes. Now the prefixes are there. If I do show BGP VPN-v4 unicast all, now I see the prefixes show up. Same thing if I do IPv6, but if I do IPv6, I still don't have anything there. So now if I add the IPv6 unicast address family here, I'm going to receive those prefixes as well. So let's go take a look at that now, and now I've received them. So that's the first thing. You have to be able to get the routes to the ASBR first. Once they're on the ASBR, you're in good shape. So the next thing to do would be to on gig 3, so do show IP interface brief. Interface gig 3, I'm going to go ahead and I'm going to apply an IP address to the main interface. So I'm going to type in IP address is going to be 12.5.6.5/24. Type in no shut, bring that interface online. I'm also going to go ahead and create a interface gig 3.101. I'm going to specify VRF forwarding is going to be C1, and that the encapsulation .1Q will be 101. The IP address in this guy is going to be 101.5.6.5/24. And then I'm going to go over to CSR6 and do the exact same thing. Okay. Now I'm going to go up to global config. I'm going to type in VRF definition C1. The RD is going to be 2:1 for the autonomous system and then the customer ID. I'm going to specify the route target import will be 2:8 and 2:16. The route target export will be 2:6. And then address family IPv4 unicast and IPv6 unicast. Okay. Now if I do show BGP VPN-v4 unicast all, I now receive routes for IPv4 and IPv6. So everything is working up to this point. Now what I have to go do is on interface gig 3, IP address is going to be 12.5.6.6/24. We're going to no shut that interface. So that brings that up. Now this will be for follow-on video. So for example, when I do option B and option C, this will allow me to do things in the global routing table instead of not having to be at the VRF level. So I'm also going to create gig 3.101. VRF forwarding is going to be C1. The encapsulation will be .1Q101. And then the IP address here is going to be 101.5.6.6/24. So there we have it. Now the next step to go through and do is to go onto, I'm going to go back to router 5, do ping VRF C1 101.5.6.6. I should be able to ping CSR6, which I can. Now I'm going to go into router BGP 1. I'm going to type in address family IPv4 VRF C1. I'm going to type in neighbor of 101.5.6.6 remote AS of 2. Okay, and then I'm going to go over to router 6 and I'm going to do the same thing. Router BGP 2 address family IPv4 VRF C1 neighbor of 101.5.6.5 remote AS of 1. Now as soon as I do that, there's going to be once the peering forms between the two neighbors, which will take a couple of seconds. Once that forms, what you're going to see is a whole bunch of additional updates that are going to come in. So now we have all these additional routes. We have 25 and 28 have now come in, and which is good. So now we do show BGP VPN-v4 unicast all. We've now learned these particular connections, which is awesome. Now if we go to route reflector 1, for example, and we do a show BGP VPN-v4 unicast all, we're learning these updates, which is what we want to see. Everything looks good from this perspective. Now if we go down to CSR1 and we do the same thing, show BGP VPN-v4 unicast all, we are not receiving those updates. You might say, well, what's going on, Rob? How come we're not receiving those updates? Well, if we were to do a debug BGP VPN-v4 unicast and take a look at the updates inbound and then do a clear IPBGP star soft, what are we going to see? For 25 and for 28, what do we have? Denied due to extended community not supported. So this means that on the provider edge routers that are receiving routes. So right now what's happening, let's whiteboard this real quick. If we were to look at this from a propagation perspective, CSR8 has propagated a prefix to CSR6. CSR6 has propagated that route to CSR5. CSR5 has propagated that route to route reflector 1. Route reflector 1 is now sending that route down to CSR1. CSR1 is denying those prefixes from being received. The reason why he's denying them is because the extended community value is not supported. What does that mean? There is no route target import for 2:8 or 2:16. And we're going to have the exact same problem on the other side, on CSR8. We're going to have the same problem here. There's a route target import policy for 2:16, but there's not one for 1:1 or 1:2. So what we need to go do is configure that. So let's go ahead and get that actually squared away. So what I'm going to go back here and do is I'm going to go on to CSR1, show run VRF, look at the route target import. I have 1:2, so I'm going to go up to global config, VRF definition C1, type in route target import 2:8 and 2:16. And all of a sudden now I will receive those, I should receive those routes now. So if I show BGP, VPN, v4, unicast, all, let's make sure that they are denied due to sending community not supported. Technically, we shouldn't need to do this with option A. Why is that being denied? Well, let's see here. So he's receiving these routes in. If we were looking at this specific prefix here, we're coming in with the route target. Oh, sorry. So it's actually, it's not the remote side that's the problem. It's the route target value here. So that's my mistake. So I apologize about that. It's not, so let's go back underneath here. Do show run VRF. It's not the inbound, so sorry. It's not 2:8. This is an option B issue and an option C issue, not an option A issue. So if we were to go back underneath here and remove this guy, let's do this. VRF definition C1 and hit the up arrow and type in no, it's not this or this. It's the fact that, so it's the route target value of 1:1. So route target import, let's wait for that to get finished. Route target import of 1:5. And now I'll be able to receive those prefixes. That was the problem. I forgot about that. But that's basically what's happening. So we have that. So we're also going to have the same problem on the other side, on the other PE routers. So they need to be able to receive those routes inbound from CSR6. But I'm also going to go ahead and set this for XR11, I believe, or 12? 11. I'm also going to do this for 11. So what I'm going to do is I'm going to type in route target import 1:11. So we'll have that. So do show run VRF. Let me go do this. Line console 0, logging synchronous. Do show run VRF. And we're going to see that we're bringing these prefixes in based off of that. Because what's happening is when the traffic leaves AS2 and comes to AS1, all the information that it had from AS2 is now stripped off. And it's being sent as a raw IP packet. It comes in on CSR5 as if it's coming from a customer. And CSR5 is then tagging it with the export value of 1:5. Unless the remote provider edge routers are going to import that, then you'll have a situation where the traffic will actually get dropped. So the route reflectors will take that in regardless of what the route target values are, because that's the inherent nature of a route reflector. But the provider edge routers need to be configured with the import values I've seen other instructors do it where they just use the same route target value, import and export across the board. And that's fine if you're initially learning MPLS Layer 3 VPN, but if you really want to optimize it and control who's doing what, and then get into some more advanced designs like overlapping VPNs or hub and spoke and things like that, then this is how you would go about doing that. So let's go ahead and take a look at it. So now we should have that. Now we're going to have to do the exact same thing on CSR 8. So on CSR 8, we do a show run VRF. We're going to see that we're doing import 216, so we need to go up to global config. A VRF definition is going to be C1. Route target import is going to be 2:6 and 2:12. So now that I've done that, let me go over to CSR2 and do the exact same thing. Let's go over here and type in VRF definition C1. Route target import is going to be 1:5 and 1:16. And then we're going to go over to XR16 and do the exact same thing. Let's go ahead and go to global config, VRF C1, route target, import, or address family, IPv4 unicast, route import route target is going to be 2:6 and 2:12. And the same thing for IPv6 unicast, 2, and there we go. And then we're going to go ahead and commit that. So now what should end up happening is on CSR1, if we were to do a show IP route VRF C1, we should see those 3 BGP routes now being added to the BGP table. And if we go over to say router 19 and we do a show IP route, we should see 3 BGP prefixes in the routing table. So we do. So now we're going to go ahead and we're going to do a trace route to 10.1.22.22. Actually, let's do 25.25, sourcing from loopback 1 numerically. And so I should follow a label. I should have a an end-to-end connection, and I do. So I can. So now let's take a look at this. So my path. Actually, let's choose green. So my first path here is going to be this guy here. This guy. Well, actually, let me. This guy here. So let me make sure I get to a. So this guy right here, this first hop, is going to be this guy right here. So this is the first one. Then the second one is going to be going from router 1 to router 3. So this would be, so this is the first hop. The second hop right here is this guy. And then the third hop is going to be 3 to 10. So this is number 3. And then the fourth hop is going from 10 to 5. So this is the fourth hop. And then the fifth hop, you'll notice that we go from a 2 label stack to a 2 label stack to a 1 label stack between 10 to 5. Well, the reason why that's happening is the PHP process is kicking in here. The transport label is being ripped off, and the VPN label is being exposed and sending the traffic down to CSR5 with label 39. Label 39 was allocated by CSR5 when CSR6 propagated a route to CSR5 inside of the VRF. So that was how that came into play. Now we jump across the wire and we get to, this is number 5 right here. Then we go to 6. We're going from 5 to 7, or in this case here it's 5 to 13. We go 6 to 13. This is number 6. And then 7 is going to be 13 to 15. And this is going to be 7. This will be and this one's a little confusing here because we have 7 is getting us from 13 to 15. And now this one here, 13 to 15, notice how it always gravitates to the next hop IP address in the trace route. So this would be 15 responding to this. This is CSR 8. Even though it's responding to the public address, here it's going to be the local interface here. So this would be 8 right here. It actually skips this one here. So what we do is it's there, and technically this is 9, and then it gets us to where we got to go because 25 is directly connected to our peering. So that's how all this comes into play. So everything's working the way that it needs to be, and it's operational. So let's just go validate the IPv6 one as well, just because I'm right here. So we're going to do a trace route. Let me clear the screen off real quick. We will show IPv6 route, and we'll trace route. Okay, so we have a problem here. So why are we not receiving any routes? So let's show IPv6 route VRF C1. So we're not receiving any routes. So show BGP VPN v6 unicast all. So we haven't received any VPN v6 prefixes. Show run VRF. Even though we are bringing them in. Oh, you know why? That's because I didn't do any VPN v6 peerings. I didn't do any of that. So since all the same things apply, so let's go ahead and do that real quick. Let's go to router 5, and we're going to go to interface gig 1.101, and we're going to type in IPv6 address is going to be 101:5:6:5/64, and do the same thing on 6. Interface gig 1.101. We'll type in IPv6 address is going to be 101:5:6:6/64. And then we're going to go to router BGP2 address family IPv6 unicast VRF C1 neighbor of 101:5:6:5 remote AS of 1. Go to router 5. Router BGP1 address family IPv6 VRF C1 neighbor of 101:5:6:6 remote AS of 2. Now that we've done that, we should get an IPv6 peering between the two. And once that forms, we should be able to exchange the routing. Let's see why that's not peering. Do ping VRF C1 101:5:6:5. No valid route for destination. Okay, so interface gig 1.101. Oh, it's because I put it on the wrong interface. Interface gig, no interface. Let's actually just grab the address real quick. So no interface gig 1.101. Interface gig 3.101. That's my mistake. I didn't catch that. Here, and then we're just going to reapply the IP address. Actually, let's do this. And same thing on here. So I think that's the problem. Yep. So no interface gig 1.101. And then we're going to do a we'll just dump this command in like so. Actually, no. Interface gig 3.101. We'll do /6. That should get us the peering momentarily. There we go. And so now that that's there, CSR1 show IPv6 route VRF C1, and there they are. Now 19 should see those prefixes as well, which he does. So now we'll do a trace route IPv6 to 10:1:25:25. Source address is going to be 10:1:19:19. We do want to do a numeric display, and then just across the board. Now it's going to be a little jumpy here because of the fact that XRV does not support the trace route option for IPv6. It times out. So because of that, we're going to have some pings that are going to fail, but we know that, so we can adjust accordingly. So, but we know it's getting there because it's traversing the path. It gets to where it's got to go. Now if I was just to do ping that source from the source of, or I'm sorry, ping that destination from a source of here, it should work all day long, which is what you want to have. So that, ladies and gentlemen, is everything that you would need to worry about in terms of how all this will come into play. Again, we'll take a look at doing this on XR in the next video and take a look at exactly how that lays out and then go from there. Until next time, guys, thanks so much for stopping by and hanging out with me, and we'll catch you guys in the next video.